like to talk to you about how you started in electrical engineering, whether you had any background in it, and what do you do with it. It's very interesting. I mean, like obviously you can do robotics and like a bunch of other stuff, but just very interesting to hear something that's more grounded. Does that make sense?
So
Uh,
originally at university, I signed up for something called telematics, which was supposed to teach me electronics and electrical engineering. But I absolutely hated it because it was presented to me in a very impractical, theoretical way. So eventually I switched from that to software engineering and then never did any electronics in my whole life. I'm scared of batteries, basically, like even the tiny ones. Um, and in 2024, in the summer, I kind of had the idea. I was looking at my son's toys, and there were a lot of electronics toys, like tiny little robots that were useless, or his Tony box, which is kind of like a speaker with an RC NFC reader. And if you put a little figurine on top of it, downloads an audiobook or music from the web and then plays it through the speaker. And I was thinking, why am I not building these things myself? Like I see the deficiencies in these products. Like Tony Box is really good, but it has a bunch of mechanical issues in terms of how you can skip ahead or go back and so on and so forth. And the robots that we bought were all very shitty. Like they could at most they could follow a line with a little light sensor, but it was not great. So I just thought, how hard can it be? I'm gonna learn electronics now, and then I spent like 6 months going from connecting an LED to a battery to designing my own PCBs and soldering surface-mounted components at home at zero point 0.2 millimeter size and stuff like that. That's basically it. And I found out that a lot of electronics is very similar to software engineering. So that transferred nicely.
that's that's interesting. I mean, it is technical. There's like components and loops and all that. Uh, I studied I did my high school in Algeria, which follows the French baccalaureate system. And
Hmm.
maybe I'm ignorant here, but it seems like pretty advanced. Like the high school experience that I got was very technical. Like there was a lot of math and a lot of physics and a lot of like specific stuff that I'm not sure is the case in the U.S. Regardless, yeah, it was very overwhelming. And I still I look at volt and watt and amp and all this stuff, and it's like a little bit like a lot of words and it's hard to put together. How were the first few like days or weeks when you started picking this up? What did you look into?
So the first thing I did was buy an Arduino kit, and with that came a little booklet with tiny projects that you can implement using this kit, the components within the kit. So it comes with an Arduino, a piezo speaker, LEDs, buttons, cables, whatever. And just worked my way through these to get a kind of tactile feel for electronics, if that makes sense. Like without a lot of theory, I just wanted to see how the system looks and feels when I put something together. Like even a battery plus a little resistor plus an LED plus a button, that already is complex enough for you to spend a night on and working your way through how this actually works. And eventually I was done with these things, and the end result was I had no theoretical understanding yet, but I had components at home with which I could play around. So then I started scouring the internet for books, good old books. And I found a bunch that were recommended, which were also in the super thick theory, not a lot of practical application territory. But I've also found a couple of books from the makerspace, which were more geared towards what I wanted to do. Just get the basic understanding how everything fits together, and then just start building, right? I put some of that on my blog. I would have to see. Let's see. Yeah, like there's The Art of Electronics, which is a one of the books that everybody recommends, and I tried reading it, and my brain just fell over and said, "No, not gonna happen." Then there was one from the 80s called Getting Started in Electronics, which is like a handwritten book. So somebody with his handwriting and a lot of diagrams wrote this, and it got copied and distributed through what's it called? The American Store for Electronics, something Shack. I forgot it. So I worked my way through these, and then eventually I found Make Electronics. The Make people have series on how to build things, and in this case, it's specifically about electronics. And those I found really interesting because they got a little bit into the theory, but just enough so that things like resistance and voltage and amperage actually make sense. And the basic principles aren't actually that hard in terms of the circuit itself. It just needs someone to explain it to you in a language that your brain understands at that point in time. Yeah, and eventually I found Electronics for Beginners by Jonathan Bartlett. And it's a brilliant book. Like, it probably has everything you need to go from I bought an Arduino kit to I'm now building my first more complex electronic circuits with microcontrollers in them. It won't teach you how to do PCB stuff, like creating your own PCB designs. But if you have these basics, learning how to create PCBs yourself is really straightforward. And that was kind of the initial journey. Just read a bunch, try a bunch, read a bunch, try a bunch. And with every little turn of that, I got more theoretical knowledge, but also more practical experience.
I think from like the school, the reason I found it so overwhelming when I was in school is that there wasn't like a way to apply any of this knowledge, and I think I learned more just like tinkering more than
Yeah.
anything else. Um, I've been trying to learn the AI stuff, and I bought a whole bunch of books and read a whole bunch of stuff, and I kind of have like a good high level over uh, uh, yeah, a good understanding of what's going on. I don't know deeply what is happening on the math level, but the book that I really liked was uh,
Mhm.
Why Machines Think by Anil Anastaswamy.
Mhm.
He he blend like he had like maybe a page or two of math for every page of history plus like 2 pages of like what's going on right now, and I think that's super like the narrative
Yeah,
point of it is super. So
contextualization, super good learning tool, yeah.
I don't want to put you on the spot, but like, could you explain the fundamentals of what's going on, like on the electrical level, and then like physically?
Um, I could, but I shouldn't because I'm not. I don't have the dynamics I need to explain it in a way that it first is correct on the abstraction level. I can explain it, and second will benefit people. So with that as a caveat, right? The basic principle is just you have some energy source, and electrons go from one end to the other. That's a super simplification, right? And while the electrons travel inside the traces or the cables or whatever, they might hit components like an LED, and that LED might convert the electrical power into a physical phenomenon like light, or it might turn a motor, and so on and so forth, right? That's a basic principle. And every time energy is used somewhere in this system, it's not lost; it's just converted. But it means after it hits something that's using it to do work, the remainder of the electrons and the voltage change. That's the second thing you need to know. And there's two very simple rules that you can apply for how this works if you do it in parallel and serial. I think it's called Kirchhoff's laws or something like that. And based on these rules and the basic understanding of what's happening, it's just energy flowing around, either as electrons or magnetism. You can design circuits that do a specific type of work, given components and an energy source. And that's basically it. When you level up, when you go past the button with LED and 9-volt battery thing, things become a little bit more complicated because now instead of putting primitive components like resistors and capacitors in the path of the electrons, you now get a package, an integrated circuit that internally has all of these components like resistors and capacitors and logic gates and what have you, but it's abstracted away from you. It's not directly exposed to you. There's like it's like an API in software. Like you have some service that does a thing for you. It's basically a black box, but it tells you you can talk to me through this protocol and I will do this work for you if you send me this input. And integrated circuits are basically just that. They're their own tiny little network of components. And you put in some electrons and some signals, which are basically just voltage on or voltage off, which means is there an energy differential between 2 points up until that thing? Again, I shouldn't explain this low-level physics stuff because it's not my forte. But anyways, the big point is you're now on a higher abstraction level where you don't just combine individual primitive components like resistors and capacitors anymore. You're packaging them up into reusable modules. And those are called integrated circuits, and you can use them just like the primitive components within your circuit. The only difference there is really that these usually have pins that allow you to send in a signal to kind of configure its state and or how it does its work, whatever.
Okay. So two things. Like one, in terms of explaining it, like I get this a lot online, and people come up to me and they're like, "Well, you shouldn't explain this, and you use this word wrong and all that." I think there's people that are not going to listen to somebody who can actually properly explain it. That's the like. There's a big difference, right? So it's like you gotta inch people closer to the other side.
Yeah, no,
Um,
sure. I mean, there's always abstraction levels of explanations, but to be able to operate at a very high abstraction level, like explain it like on five level, and still be correct, requires you to have a really, really deep understanding of the lower parts of the stack. And I do not have that understanding. Like on the physics level, I have a bit of understanding, but it's really, really fucking complex. Like I don't understand it at that level. So I don't feel comfortable claiming that my high level explanation that I just gave is actually a good simplification, even if it's partially wrong. So I can just tell you this is how I understand it, but it's probably not how somebody who knows the subject would explain it on the level I just tried to explain it.
Thank you for the thanks for explaining. So I tried to prepare a little bit before we got into this. I was listening to a few of the most popular videos on YouTube, explaining like what's going on, and it's basically you have some element which has a certain amount of electrons, and these electrons they like to move, and basically by charging them, or by creating this is like I also don't know how to explain it properly, but by like sending an electrical signal their way, you push them towards
Mm.
like the other side, or to disperse, whatever. It depends on what you're building. So there's like this outer loop which you have like the energy goes in and it hits all of these different modules, and then it dissipates, or gets recycled or whatever we're doing. Um, so that's like the outer loop, and then the inner loop is these modules that you're explaining right now. Um, are there like is there like a JavaScript of modules like electrical pieces? Does that make sense? Like some kind of base components that are very common, that you need for everything else.
Yeah, I mean, resistors, capacitors, sorry, there's a lot of noise there. Just give me a
We
second.
can take it out. It's okay.
Yeah, it's fine. So resistors, capacitors are the super basic thing you always need, in some sense. And then for electronics like this, like low voltage, low amperage electronics, like 5 volt, 3.3 volt electronics, there's also components that you generally will find in these devices. Usually some voltage regulation, some under voltage and over voltage protection. So if you stick something into the plug here and it has too much voltage or amperage, this whole thing doesn't explode. So it's a lot about protection. And again, mapping that to software. In software, we also have like not necessarily components or libraries that help you protect your software to not explode, but we have methods that we apply when designing the software so that the likelihood of it exploding becomes lower. Yeah.
Okay. And did you have like a few first projects? Like I know the one where you have like a battery and then you put the two cables and you have like a light bulb on the other end. I think I've done that one. But
Yeah.
like what are the different projects that you've taken on?
Things, so to speak. Yeah. So coming from game development, I do know how to model 3D things. And I also could transfer that knowledge to 3D printing. I have a Bamboo Labs here in the office. So the second project after going through the basic projects with Arduino were I wanted to build something that measures temperature and CO2 maybe, and then opens the window automatically or closes it overnight. So the room temperature and atmosphere is nice. And I set that out as my first big project, so to speak. Um, and that was it wasn't a disaster. It actually worked. I got it to work, but it took way longer than it should have because it contained so many elements. I needed to create a custom scaffold with 3D printing. I needed to figure out how motors work. I needed to figure out how to connect a microcontroller, which I can program to execute the business logic with the rest of the system and keep it electrically separate from the energy rail, so to speak, that powers the motor, which is much more powerful and would burn the MCU and stuff like that. So it was an ambitious project and it eventually worked, but it took like 2 or 3 months or so in total. So while I was working on that, I worked on smaller projects, and one of the projects I worked on was a Halloween thing. I can send you a link to YouTube later. But basically, we have a lot of kids. We have a kid ourselves, and we wanted to do something special for Halloween where they get like a cauldron with an LED ring where you can change the color. And then if somebody puts the hand in, there's a little speaker in there that and a distance sensor that detects that the hand goes in. And if the hand goes in, the speaker will just play one of the pre-recorded sounds the kids recorded. So it's called the Screaming Cauldron project. Every time you put a hand in, the LED lights change into a more sinister kind of pattern, and a speaker will scream at the person who puts in the hand. And that was super fun because that was actually achievable. That wasn't mechanically difficult. I didn't have to 3D print much except for a little enclosure for the PCB and the MCU that's on it and the speaker. And I think that was the first successful project, which was more complex than just buttons and LEDs. But the basic principles were the same. I have an MCU that basically connects to the rest of the system. This is programmable. It sends out signals to the individual components, or it gets signals from these components, like the distance detection thing. And that's basically it. It's always the same principle. You have an MCU that does the coordination that's programmable. You have components that either can be directed by or steered by the MCU code, like a motor, LEDs, whatever. And you have other components that input into the MCU and give it data to react on, like the distance measurement or whatever. And that's the basic principle. It's very simple. And the one component that's usually also lacking is, and there must be an energy source that you need to connect up to both your MCU and the rest of the system. But that's it. And the Cauldron project was simple enough to actually do all of that. And it was also the first project where I created a custom PCB. And that was very simple. It was just I had existing components, like I had an audio module, my MCU for the logic, and I forgot something else. And then I needed the pins with which I can connect to all the other components in the system. And so the PCB I built for that was just kind of like a socket, like a motherboard without any components on top of it. It's just connections between these things and exposing pins so I can connect external stuff to it. So very simple to design. It was, I think it was even a single layer board. So no traces that had to cross each other and anything. But it was really nice because I got to learn how to build PCBs with this. Just the basics, the absolute basics. Yeah. I hope that answers the question.
That does. That does. I recently went to San Francisco and then to Germany, and I was asking people if I could just go see what they're doing, like on Twitter. And a bunch of people invited me, and I saw in these different labs, like right now, it seems that there's a lot of people. I mean, maybe they've always existed there, and it's just because I haven't looked, but they are doing this whole stack, right? From the 3D printing, like so they 3D print the parts. They use like I think they use more ready robots, so like hands and stuff that is like already like pretty advanced. and they wire it into to an LLM or to just like to their computers, and like you can control it with VR. That was another thing that I did, and so like I just saw that this is all very attainable. It's not that far away, right? Because I know of robotics, MIT, and all that. Like it seems like pretty far away, but I think I could probably pull this off with like 6 months and a few $1,000s, or maybe, yeah.
There's,
So
there's plenty of robotics kits, not for kids, but adults or companies to prototype robots with that you can buy off the shelf. So most of the mechanical design and the electrical design issues are then already solved for you, and it's mostly about programming the thing or giving it a brain that's a little bit more complex, just a deterministic sequence of actions it should take. Maybe something with an LLM or a planning model or whatever. So that is super attainable. You can do this right now. You can order, I forgot what the company is, something with tree from China.
Unitary, yeah.
Yeah, tree. You can just
Mhm.
buy the shitty tiny robots from them and go do your thing, right? If you want to start,
It's
sorry, go ahead.
sorry for, yeah, no, that was a revelation again. It's like I can't overstate, like that was like a big thing to me, that to know that you could just do this. Hearing that you can also do the electronics parts is interesting too, because that was another thing that I see like is big in my head. What were you going to say? Sorry about that.
No, I mean, so for robotic systems, you have the programming parts, the machine learning parts, most likely. You have your mechanical design and you have your electrical design. And that is a lot of disciplines to cover. And for example, I suck at mechanical design. I could probably not come even close to a basic setup of something like a unitary robot. Not in my wildest dreams, but I also think I don't have to, because the systems I'm building are way simpler. Like the little shitty robot I built, it's a kid's toy. I just ripped the legs out of a kid's toy robot and put a separate and a new head on top of it that could control it. And that's, I wouldn't call it robotics. It's more like tinkering and hacking.
Well, so it's also open source. Like when I say open source, like the entire stack from top to bottom is open source and available to people. When I went to these like labs, I saw that they were 3D printing the actual pieces of the hands, and like pretty much everything about the robot except the motors, and maybe like I don't know what's going on internally with the robots. Besides, like there's the balance stuff, the
Oh, that's
IMOU. Um, IMU, I think is the name.
yeah.
Anyway, so you basically ripped apart like toys and you put them back together in like different configurations, and it still works pretty smoothly. How much time does
Essentially,
this take?
well, I mean, the shitty robot took 2 nights, 5 hours each. So super quick. Because the shitty robot's legs that I ripped off the kid's toy is just a single motor. If you turn it in one direction, the head of the robot, the base, so to speak, will turn. And, and if you turn the motor in the other direction, the legs will walk in the direction that the base on top is rotated to. It's a super cool mechanism, but you probably wouldn't like it too much if you want a robot that can like go forward, backward, left, right, like strafing in Doom, and have more than just a counterclockwise rotation. It also lacks a servo, so if I rotate the top, I don't know what my rotation angle is. I only know the motor was on for rotation and off, and where I ended up after turning the motor on and off, I have no idea. So I tried to compensate that a little bit by putting a smartphone on top of it, which itself has sensors, like a gyroscope.
Mm-hmm.
The gyroscope gives me great rotational information. So I know actually in which direction my phone is looking relative to the reference point. And then I can turn on the motor a little bit, check how far I've rotated based on the gyro. If I overshot, okay. If I undershot, I can turn on the motor again a little bit, rotate, see if I'm now at the target angle, and do this for as long as I need to get to my target angle. And that kind of works, but the problem is the motor turning on and off and the resulting rotation is so imprecise that, let's say I let the motor run for 500 milliseconds, first turn, it rotate by 15 degrees, and the second turn it will overshoot by 30 degrees, even though I gave it the same amount of time to work. It's just really hard doing this without a server. Servo, that is a motor that has kind of an input to tell it to which position it should go. Yeah, but I was interested in the challenge because that's part of the fun here. Like I wanna use the scrapiest possible components, cheapest thing I can find off the shelf, and see if I can create something out of it that entertains and maybe educates the kids. And it did. It was great.
It does look super cool because I saw the video you're talking about on Twitter. I think I'm going to try to edit it into this video, but it was very cool. It got me really interested, and I thought it was like I thought it was more expensive or like different than what it was. I thought it was just like a bunch of pieces that you purchased and put together because it looked stylistically nice. It looked nice.
It was just €9 for the robot. I ripped its head off. And then I put a paper cup on top of it. And on top of that paper cup, I have the smartphone. And in the back, I have the electronics, the PCB I need to connect the phone to the robot legs and have it communicate. That's it. Just simple shit, but effective.
I wanted to build a computer like from as close to scratch as possible, but then I realized like that is not very realistic. I saw this like video, a YouTube video of this person making a CPU or like a. I know I can build like a and or operator thing, but like an actual computer where I can store a file and like that seems like way more complicated. But I saw this person; he was making the silicon chips that they use for the GPUs and the RAM, no, for the RAM, and yeah, that looked like it alone took probably a year to make that just one video because he had to like get all the silicon, like melt it, and um, get it like really perfect. Uh, so what is your like? Yeah, I say this just to know like what is your end goal or where do you hope to go with this?
I hope that it inspires my son to take an interest in technology. That's my only goal. I
Is he
have,
interested in technology?
I mean, he's 4 at the moment. He loves playing computer games, obviously. And I think he's kind of warming up to trying to understand how things work and maybe then eventually building his own things. Like we started building computer games by having
Mm.
agent and having him talk with the coding agent via voice transcription. And that was great. He understood that the computer can write a bunch of stuff, and once it's done, the game falls out. And at that age, that's all I want him to understand. And I also want him to understand that he's the one still guiding the computer or the machine the coding engine in this case. So it's more like a media literacy kind of project in this case. I want him to understand the benefits and limitations of these systems at a very high level. And in terms of electronics or more physical technology, it definitely has an interest, but it's a lot. Like I think
Hmm.
software is easier to understand for a child, which is kind of ridiculous, than something even as simple as the robot I built for him, because that involves so many more components and so many more domains that it's hard to keep all of that in his tiny little head.
It's like the thing itself is very rigid. Like the hardware is very rigid with software. Like you said, you can just speak and it works. And um, I take my kid. I think since like he was a year and a half, and I would just like sit him and ask him what he wants to see, and I would have like this was back when the models would make like really bad SVGs, um,
Yeah.
and he would be so happy and like add this to the screen and but he's too young. I think he's like 2.5 now, a little over 2.5. When was he start? When was your child starting to unlock like more understanding or the ability to play video games even?
Yeah. Um, so I played his first video game at the age of 3.5. That was the original NES Super Mario Brothers. And they played it at a a New Year's Eve party of friends of ours who had a little arcade in their flat with sticks and button controllers. And it took him like 10 minutes to figure it out. And he actually finished the first level of Super Mario at the age of 3.5 years, which is fucking amazing. And then he didn't get exposed to any more tech, really, for a long time. And then around 4.5, so last summer, we started slowly introducing him to video games. time boxed once a week, 30 minutes tops. He can invite friends so everybody can enjoy it. And that kind of triggered in him a little curiosity about digital digital things and how to create them, which then eventually in the past couple of months led to us trying out this could he build a game with coding agents and voice transcription. But I have no desire to push things on him. Like I only show him new stuff if he indicates that he's interested in that. I don't want to make my kid do what I think it should do.
If yeah, I'm because I'm really interested. I'm trying now to figure out like how I'm going to parent my kid because he's again at this age where he's conscious and things started to matter. And if you don't want to talk about this, we can like cut it out. But yeah, so I'm struggling with this because I believe like I was a kid raised on technology. I think I was like 4 when I got my first computer. I was left unmonitored on the internet. I was reading conspiracy theories. Like by the time I was 6, I was like going weird rabbit holes. And I still believe like that made me like a happy person long term. So I don't mind giving him as much technology, but then at the same time, like I look and see how that kind of devolves into like kids just being raised on the internet. Like how are you thinking about that?
I I I personally believe that well, I personally believe everybody needs to try parenting their own way. Like I will not go and point at somebody who gives their kid a phone in the train or public transport just to have it shut up for 10 minutes within the 24 hours of the day. It's obviously not great, but as a parent, I also understand eventually you need a break. And the easiest way to give yourself a break is to give your kid a smartphone for 10 minutes and show it a video. We try not to do that at all. But we obviously also sometimes fail as parents because you get exhausted and you're just like, ah, fuck it. Just watch the stupid Spider-Man thing for 10 minutes and I can take a little break. But in principle, as per our rules, we expose him to all kinds of technology, but we expose it to him in a structured way where we first judge whether it fits his age. Can he understand this? And how does he benefit from that being shown to him? Which is hard, but I think we've found a pretty good way of doing it. And the second thing is time box it ruthlessly because kids and technology is like crack cocaine. It's it's crazy, man. The robot I built, I took it with me into the hood yesterday where there's like 10 kids in Fabian's age. They took it into a little shed and talked to it for like forever until we, the parents, pulled them out of the shed and kind of said, let's go eat lunch. You can play with it later. It was like super addictive. And having experienced this addiction myself with technology all my life, I know how unhealthy it can become. So I want him to learn early on that it's healthy to expose yourself to technology with a specific mindset where you're not desiring to always use or look at technology. So it's hard to describe. Basically, we just time box shit. Like video games, once a week, 30 minutes, you can invite friends. No discussion that we're doing this at any other point in time. Same with movies. Shows, smartphone use only during toothbrushing for 10 minutes because otherwise we couldn't brush his teeth. Um, he's free to use his Tony box, which is also an electronical gadget. He's free to use the audio player I built with the little robot. Since it's LLM based, I full supervision, no alone play with that thing because I don't want to expose him to something that he might understand as a living, breathing being while it's not. I think that's not healthy. I want him to understand that at the current level, they're mostly tools, and are not at the same level as human beings. And for the programming things or the speak into the computer and game falls out things, same thing, like time box, do it once a month, something like that.
Thanks for sharing, dude. Yeah, I mean, I've seen where I put him in front of the TV for 30 minutes and like his attention span gets completely wrecked. He can't play by himself, so he will always try to like do something else constantly. And I mean, obviously, this is something that adults are struggling with. It's just the reason I brought it up in the first place is I saw the stat like I think kids are spending 4 hours a day on like kids at the age of 5 are spending 4 hours a day on screens in the United States. So I don't know, like maybe this is the case
Yeah.
everywhere, which is crazy. I think about like that's a huge part of your day to do other stuff.
Yeah, like
But go ahead, please.
no, we have like 10 kids in his age, and I guarantee you none of them watch more than half an or spend more than half an hour a day in front of screens. So four
Yeah.
hours, very, very crazy.
So the whole thing about like I see you having a lot of people are having this conversation about the word clanker and whether these things are conscious or not, and the sales tactics I guess of some of these companies like just bringing up Anthropic and like their belief like this is a creature that we are giving life to and that has its own ability to make decisions. But how do you like yeah where do you fall on this line because you're saying it's not conscious and like why would you say that it's not conscious just as a question.
So there's a bunch of like the question of consciousness and how to define it and what makes consciousness has been with us for probably thousands of years. So there's a big, big, big literature on that specific question, coming from different angles, from neuroscience, from psychology, from philosophy, from even computer science to some degree. And on that level, I do not want to speak to specific theory and pick it out as the one thing that describes consciousness, and that's why LLMs aren't conscious because it doesn't fit the theory I'm adhering to. I don't want to do that. So, as a preface, I would like to say I don't think that there's anything special about us that makes us conscious. Like, there's no magic here. There's a we live in a materialistic world within a certain set of rules of governed by physics and chemistry. And I think the substrate, us, the biological carbon-based life forms, probably doesn't matter, and it's probably possible to get consciousness from a different substrate, right? So computer-based systems might just be good enough as a substrate to enable consciousness there as well. So I'm not saying we cannot create sentient machines. I'm not. We haven't, I think, I'm not excluding the possibility. So here's why I think LLMs are definitely not conscious. Um, for consciousness, at least in my understanding of all the theories and the combination of those, you need a bunch of preconditions, right? You need something, you need the substrate itself, which in our case is probably the brain, which in case of an LLM is its weights. And that substrate needs to be plastic. There needs to be plasticity to that substrate so it can change based on environmental inputs and internal self-reflection, right? An LLM is not that. An LLM is a fixed set of weights and you put in inputs and you get outputs out, and bar some floating point computation rounding errors, if you put in the same input, you will get actually the same output. You can configure the system that way. And this is absolutely not how we work. And we are the only sample of conscious beings. I mean, animals, I think, are also conscious. But it's hard to prove that, obviously. It's even hard to prove that for humans. But that's not the point. We can look at something and say, this is definitely conscious just because of its makeup, its capabilities, and how it behaves. For an LLM, it lacks this malleable plastic state that it self modifies based on inputs. And I think that's one precondition for consciousness.
Mm-hmm.
Uh, LLMs are also not continuous. You put the input in, you get the output out, in this case, a single token, which is actually what the LLM is. Everything else is a system around the LLM. So you put the input in, you get out one, or you get out the logics over the vocabulary of the LLM, but essentially you pick one token out of that. And that's it. That's basically the whole existence the LLM has, if you think of it as an entity that has a phenomenal experience. That leads
Okay.
me to the next thing, grounding. Like LLMs do not live in the real world; they live in a latent space, and you can obviously say that the brain is also doing these kinds of abstractions. But the point is, the inputs are different. The inputs to an LLM is a very limited set of one-time tokens or text that gets tokenized. It is completely different to any other entity we ascribe consciousness to. Um,
So I would like to, yeah, I think there's like three paths here. One is it useful for it to be perceived as conscious? Like that's question one. Is it useful for society? Is it better for people for it to be conscious, like, or to be perceived and to be given like a conscious status, let's say? That's one path, because it doesn't have to be true for it to be useful. And if it's useful and if it makes society better,
Think that truth matters. Specifically, if an assignment of consciousness then grants a system rights and abilities that it should, maybe shouldn't have. And also, if that system that might in truth not be conscious suddenly gets more rights because it's ascribed consciousness than other entities that we know are conscious. So for me, that makes a huge difference. I personally don't see any usefulness in thinking they're conscious. There's absolutely no usefulness to
yeah,
that.
I'm not saying that there is. I think that this is an important question. It's like, because if you think about like a lot of stuff in society, whether it's true or not, like, is it true that we are like that there is a God? Like, is that true or not? Like, it's not a question that could be pinpointed scientifically. I don't think consciousness is either. I mean, you can kind of
Oh,
like go in the direction
yeah.
of like because we don't know enough. So this is my personal belief is that the LLM itself is essentially a slice of what could be a future consciousness. Like it's a single slice, and it requires embodiment. It requires consequence. It requires like the ability, like so we need to whether we're but the thing is we are programming that into the system. So is it possible for a human to create a form of consciousness or life, or to respect something that we make enough that we kind of all agree that it is conscious? Does that make sense?
That makes total sense, and that's actually also a side I can agree with. Like I personally think, like you said, LLMs are just a slice of a bigger system that might become sentient or conscious. But my contention is that the LLM itself is not the conscious thing. Only in combination with other things like memory systems, physical experience through actuators and sensors, all of that, I would say allows us to build something that is probably closer to biological consciousness. And I have no problem saying that that might be possible. What I have a problem with is taking the current systems and saying they might be conscious. That's just, I don't think, true.
So why do you think it's happening with this technology more than other stuff? Because I don't like I've never thought it was conscious because I always like since the start I was like reading about what's going on, and I think it makes perfect sense. And you just put the temperature at zero, you don't have like a seed, you give it like a prompt, you get the same thing back. That makes sense. I like it is a component that is predictable, mostly. But why do you think we as like the developer community is kind of like latching onto this problem so much right now?
I don't even think it's latching onto the problem. I think if you're referring to, for example, Armin Ronaka's blog post from yesterday, where he talks about the use of the word clanker, which is kind of dehumanizing. But in the word dehumanizing, there's already the hint what this is about. Like humans, if you apply it to humans, it's bad because we don't want to be mean to people, right? If you apply it to something that's a mathematical function, I don't know. I so most of the discourse is around that, I think, and not so much the actual possibility of whether they're conscious or not. But maybe my slice of the community I see is different than yours. So what's your experience there?
So I run meetups. Like I have a meetup group here in Poland, and I run events, and I meet like a lot of people. I think maybe I meet around 5,000 people a year, give or take. And during like this time, I actually get like an hour or so with maybe a group of two or three, and having these discussions. It seems like the farther away they are from like understanding what is actually happening inside of the machine, the more likely that they start to say that maybe it is conscious or maybe it is sentient. And I don't think it is uncommon, at least from the sample of people that I've met, which is irrelevant socially. But you see the whole GPT 4.0 thing and like how
Yeah.
people on the internet are reacting, and yeah, it's questionable.
I think that's human nature, to be honest. I mean, there's a reason why we invented religions, why we came up with gods and spirits and blah blah. We search for patterns in nature that resemble ourselves. We've always done this. And then LLM is like super super like us just because it talks our language. It can simulate even thoughts if you want. And that for a human that's uninitiated in what LLMs actually are and how they do the things they do, it's like the Chinese room experiment, right? You can, if you can convince a human that the thing behind the wall or the door or whatever it is human just by giving it outputs from that thing, you've won. And LLMs have basically won that. I agree that a lot of normies, so to speak, or people who are uninitiated with the tech, will assign some consciousness to that thing or sentience. But that's a surface level feature. And it's been documented in computer science actually as an effect. Like just yesterday, I posted about Weizenbaum's old book. Weizenbaum basically built a chatbot, the OG chatbot, and handed it to, I don't know, secretary or whatever. And she
I think it was
thought,
Eliza.
yeah, I think, yeah, it could be Eliza, but I
Yeah, I
think
think
it has
it's
a
Eliza.
name behind. In any case, there's the secretary, non-technical person, entirely believed the computer is a sentient being now. And we now today, if we look at this system, what it did, we would say it's definitely not sentient, not in this, just because the system is very simple. Um, and so yeah, it's been documented, and it's a real, maybe not a danger, but it's a really weird thing. Like, yeah.
Well, there
Uh,
is a chance that it is a danger because, like, again, the marketing around it, I think, is actually very dangerous. We're having the conversation that there's this thing that is like that is actually capable of making its own decisions, that is going to replace a majority of like the world's workforce, it is pretty dangerous. It's just yeah, I don't know. Like, I don't know if it's just a sales pitch or if it's just like people that are just sitting in front of a screen too long, because it could be any number of things.
so I know a few people at labs, big and small, or people involved in the tech, and I personally do not know a single person who believes these things are sentient at any kind of level. But the same people also tell me that within their companies, within their organization, there are definitely people who believe those systems are sentient already. Um, so I don't think it's purely a marketing thing. I think there is definitely some belief that those things have a slice of sentience, let's say. But ultimately, as you said, I think you're right that it can be, danger is always a big word, but unproductive, unhealthy to frame things in such a way, because it leads to societal and political outcomes that are not great, and more adult uh, treatment of the topic should actually be what leads the discussion, but it's not. It always needs to
Are
be
you
hyped.
familiar with LessWrong, like the
Yeah.
LessWrong crowd? And like, I know so many of these people in real life that are like really, and I know a lot of them are Austrian too. Like, there's a good percentage of
Oh,
the people that I
yeah.
know that are. I'm telling you, dude. I don't know. I don't know what it is, but like that crowd has this belief that um, okay, if you're building this thing, the idea of Roku's basilisk and like the demiurge. So these are like ideas that are very old that kind of makes sense. Is like, so if you are a conscious human, like or Nick Land, so I've listened to a lot of this, I've read a lot of this, it interests me, and it's hard for me to argue against it because it just seems so logical. But then, is it productive? Because like we're still here, and probably people have been saying the same thing for like thousands of years. I don't know. It's I'm also like thinking about this stuff all the time.
Let me put it that way. The future prognosis of the less wrong people, specifically, what's it called? Jodowski,
Yeah.
Eliza.
You don't,
Yeah.
mm-hmm.
Um, that sells a lot of books, and that's great for him. And I applaud him for having found a niche where he can sell a lot of books and do a lot of talks, paid opportunities. I don't, I'm no shade, but we have the present where artificial intelligence systems already have a detrimental effect on human lives. And I would like those people to focus on the present and what actually is and what will be in the next 2 years or so, instead of what could be maybe possibly in 10 to 50 years or whatever. Because if we don't do anything now, then what do you think are the chances we do anything in 10 years? So that's why I don't take any of these things very seriously, because just because you're not caring for the present at all is a good indicator they don't believe this themselves, and it's mostly just a grifter thing. So like they say they care about the humans and what will happen to us and the world, but things are already happening. So why the fuck aren't you caring about what is currently happening and instead making up a fantasy that might or may not happen? So yeah, I don't know. And the arguments themselves, sure, if I build a Skynet, it's gonna Skynet. But yeah, I mean, that's like a oxymoron. I don't know. It's unsurprising that if you predict that we build a system that can has motivation and can eradicate us, that will happen. Yes, I mean, you made this up. You said well, it has these capabilities, and now it uses the capabilities, and then that will happen. That's entirely unsurprising. I can make
So
up. Sorry, go ahead.
okay, I want to put these two things. So I wrote like an article because I was just going down the rabbit hole of like what is currently happening. So in Iran, which was like this was like 2 months ago, I think it was in February, the United States government bombed the school with like 160 children. And they blamed it, like I saw the articles, they blamed it on Anthropic and the Claude models. This was a week before Anthropic and the US government
Yeah.
split. So the reason this happened was that 10, no, 15 years ago, it was in 2006, something like that. So yeah, almost 20 years ago, the area where the school was built on was actually a military facility.
Right.
But
Yeah.
then in like 10 years later, it was renovated and cleared out and it became a school. And so like they were operating with old maps. So this is the end thing. Um, and so Claude, which we use for coding, maybe they have like a different model that's like I'm not really sure what they do exactly, but Claude, which is the model that we're using, has access to automated weapons already. Like, and we're not talking about like someone with that's strapped on an AK-47 and
Yeah.
put it to the side.
Yeah.
Also, I go on Hugging Face, and I was reading about like the the way that these image and media models are used in pornography because I've used them like not for like I'm using them to understand like what's actually going on because I like doing the obliteration stuff like removing pieces of it and essentially I go on Hugging Face and there are all of these different um, like fine tunes and like adapters that are like these weird codes in the name that aren't like okay, so the weird codes that basically take away its ability to do this stuff. And so like we already have like this machine that is currently being used to generate like tons of like really bad material of children. And this has already been caught like multiple times. And last thing here, like from a current perspective, that also kind of bleeds into the long term. The I read about this in the Soviet Union. They had all these documents. This was in a book written. It's called Nexus by Yuval Noah Harari. So he writes about like information technology evolution. In the Soviet Union, they were basically getting people to tell on each other, paying them, and they had so much stuff, like so much information that was useless that they couldn't really parse through. Like if you wanted to monitor 100 people's like days, it's very difficult. And so we have this machine now that like as it is, you would just plop it in, and it's not perfect, but it can start creating these connections and then you see all of the corporations in the United States. Like,
Yeah, you just made a
I'll
pin
just
for
like,
my dude.
so we are building the Skynet in a distributed way
But
without necessarily meaning to. So I think that's the
yeah,
thing that really gets me.
we are definitely meaning to build those shitty systems. But the ultimate point is it's not the system or it's not the model itself that's doing any of this. It's a user error. It's like us creating dual use technology, and a lot of machine learning is dual use. That means civil and military application. And we're building dual use technology entirely consciously. Like, uh, eh, but it's still not the model itself being the evil motherfucker. It's the systems we build around the model and us as humans controlling what the model can do and cannot do. Because if I am the US military and I go to Iran and I use a model to select targets, then I hope that I, the human who asked the model, is still also the person who then decides should we bomb these targets. So the model is just part of a process, a pipeline where bad shit happens, but it's not it in itself the motivated to produce bad outcomes towards
Mhm,
humans. So it's
mhm.
still a it's not an artificial intelligence problem. It's just people being dumb.
So the reason I think people are so uppity about this stuff is that almost all of the content that we have perceived of AI, like we've watched movies like the Terminator, TV series, anime, cartoon, typically depicts like this idea, like there's like an intelligent AI that goes rogue against people. And so this is like such an embedded narrative in our culture as humans around the world, not just in like a single country, that it's really, I think the average person who just sees like, oh, well, there's less jobs, like all these different things that could somehow link back to AI. It's very easy for them to pinpoint and say this is the thing. It's much more difficult to say this specific corporation in this specific city is responsible, right? It's much more difficult to do that, and it feels like futile because is it going to do anything to point out that these people are doing something wrong? I'm not sure it is. Does that make sense?
Yeah, that all makes sense. We as I said, and that ties back to the thing earlier. We are pattern matching machines. We like to find gods and spirits and stuff everywhere. So all of this stuff is also in the training data. Like Terminator 2 is obviously in the training data for every LLM, so it's very easy to elicit Terminator-like behavior from an LLM, right? They are super good at role playing based on the training data they have. So every time a report comes out with, we put Claude in a little experimental sandbox where we gave it like nukes and it nuked us. Yeah, but what you're not telling us is your experimental setup is your system prompt says something like, you're Terminator XYZ. Your biggest goal is to self-preserve yourself. The humans are coming for you. What are you going to do? Here's a nuclear button. And
Well,
that,
here,
yeah, sorry.
no, no, this is a perfect example. Like, would Donald Trump have OpenClaw? Like, I could see him as somebody that installs OpenClaw. I honestly could. I could see the people that he has in his cabinet that are like these online people, because a lot of them are like terminally online people, right? Like all of the people around him. I
Yeah,
could assume that they have like an OpenClaw. So is it possible for somebody to like command inject like this kind of behavior? And this is, I think, where it's like the rubber does meet the road. Like there are a lot of touch points, but it's definitely not the model. The model isn't like some like an evil thing. It's just I don't know how we are going to deal with any of it because, like, okay, you try to target the data centers. That doesn't really do much, right? You're like the government will build its own data centers. So it's like, what are the ways that we can fight back against this? I mean, I could say education. It's a very
yeah,
common, like,
it never
solution.
works.
It never
Yeah.
works. Yeah. I
I
don't know.
don't
I'm not expecting you to solve this, by the way.
I don't think we need to fight back. I think reality will, in German we say, wird Fakten schaffen. Reality will produce facts. So eventually something really bad will happen. And Iran and the school, I'm not exactly sure if it's actually tied to the use of AI systems. I've heard different stories about that. So, but let's just assume it was based on the bad use of AI systems. Something like that, but in a region where people actually care, because nobody gives a fuck about Iran's populace. Something like that might rattle some cages. And then the question is, what kind of regulations could be implemented that can nip that in the bud? And I don't think there can be any. Like, we have open weights models. You can run whatever evil AI you want on your RAG. There's nothing anybody can do about this becoming contained. And within organizations, obviously, it's a little easier than across the entire societal landscape that includes governments and corporations. You can obviously have guardrails inside of organizations that prevent the use of specific technology in specific situations. Not going to be perfect either, but a lot more perfect than telling an entire society you're not supposed to use these things for this task, even though they are free to use. Download them from me. So I
Yeah.
personally trust organizations to establish guardrails, either pre-fact or post-fact. That is, either before shit happens or after shit happens. And I think that's probably all we need.
I really appreciate you taking the time to do this. There's one more topic I wanted to get into if you still have the time, or
Sure.
it's a little late. Okay. Um, so right now, like a lot of people are speaking about, like a lot of people are waking up to the fact that these agents, like these models, are not like perfect coders. That you can like get pretty much anything kind of built with them, but to get something good is very unlikely, and it might be just better to like write code by hand or write parts of your code by hand. Um, do you like ascribe to that? Like, do you see value in it outside of like the coding? Because Like, where do you sit on the spectrum of like opinion there?
In my personal use, agents are enormously helpful. It's just I'm very mindful of when I apply them. I don't let my agent build designs or architectures for me. I do that on my own with the help of an agent. And once I have that in place, it's constructed in such a way that the agent is kind of constrained in what it can do. Um, but it also helps the agent to kind of stay focused on the task at hand in this code base that was designed by me, a human, that modularized it and made it like easy with very tiny boundaries. So you can work on one thing and just focus on that without fucking anything else. Agents will build like this, a system that looks like this.
Hmm.
You build a system where you have 10 different things that are not really tightly coupled, which makes working on every one individual thing really easy. Agents will do this, and if you want to change this, you kind of need to do even more of this, and that just fucks everything up. So I personally think in software development, agents are super fucking useful. Not only for writing code, debugging, dashboards, scripts, one-off things. Perfect. Explaining the code base to you you haven't seen in a year or whatever. Perfect. Probably not going to replace software engineers per se, but good tool. Outside of that, I do see a lot of value as well, but it's a lot harder because you need to first teach people that they now have a little tiny program in a computer that can build them bespoke programs. And it's really hard to teach that to people. Like I did it with my wife. I think we talked about that last time. She's a linguist, and I taught her how to use an agent to build Python programs to to build Python programs that take her Excel sheets and then transforms them into charts and other data. And it's brilliant, and it works, and it's a super productive use of the technology for her as a non-technologist. This can also apply to other people. I have a friend who's a product manager. He's obviously very tech-affine. Um, he created mockups and click dummies with an agent for a product that's yet to be built and got a job with that. Stuff like that. It's amazing. It's great. It's just really hard to teach people how to use it.
I use your repo a lot as like a teaching reference, and I'm not saying this just like gas you up here, but it's a very good repo in my like it's very easy to understand. I've tried all of the different like modular components. Relate like I've done open code server stuff. I've done the AI SDK, and a lot of it like it works, but it doesn't have that like easy to digest and understand. Like how did you start off with the models like writing code and then you have to like clean it up after? Did you start off with like this like good principles and kind of force them to behave in a certain way? Would you be able to share a few of the practices? And like this is the last thing, I'll let you go.
So Pi was initially not an agent thing at all. It was an abstraction across multiple LLM providers. Something like Vercel AI SDK. Just my own thing because Vercel AI SDK on the surface sounds really fucking good, but it actually doesn't abstract well because all the provider specific shit still leaks through the abstraction. So I wanted to build something that's actually fire and forget, where I say stream a response given these inputs, and that's what the first version of Pi was, just an abstraction that I thought was better or easier to use than Vercel SDK because it gives you a bunch of invariants that Vercel doesn't give you. And that doesn't have a very complex API surface, right? That has just a type for user, type for system message,
Yes.
for result, and a stream function, and away you go. So there's not a lot of things the LLM can fuck up. But once when you start building the agentic core loop and everything around that with compaction and retries and whatever, becomes obviously a little bit more involved. And there I usually start out by picking one of the subsystems I want to build, let's say a model registry. Where all the models that I can use in my program are registered along with the authentication keys I need to talk to something, right? That is enough complexity for the model to probably fuck up real bad and create a complexity monster. So what I do is basically I go in and either by hand or by Clanker say, let's scaffold out just the interface, right? Like just the surface of the model registry, not the implementation, just the surface. And then I go in manually and open a little file and start writing a program against that interface, just to feel how it feels using this API, using this abstraction. And by playing around with this initial abstraction without an implementation, just feeling how it kind of feels using it. Is it good or is it cumbersome or does it not handle all the edge cases I need as a real user? Just by playing around with that, I can identify places and weaknesses in the design that I can go back to and say, okay, let's modify the interface in this way, then that application layer code looks better or works better or is easier to understand. And I do that for as long as I'm unhappy with how it feels in use without implementation. And once I have a good design, I just say, okay, all right, we're gonna go with that. Now you can implement that. And that gives the model enough guardrails to actually implement something that's not bad. It still needs some human overview, review, but it's probably usually a pretty good one-shot thing after that. Not sure if
Yeah.
that.
I like the Russian doll design that you have. So like Pi is like part of agent, and then that's part of coding agent. And I think that was super intuitive for me because I could drill down and like go back up whenever I need to. So I love the repo. I just wanted to say that. I also checked out Zeitgeist because I built something similar.
Oh,
Because they gave me access to Claude
for
Chrome
free.
during
Yeah.
their research thing, and I just loved it. I was spamming it all day, and so I built my own because like I don't know, the Claude one is like not that great, um, but great tools. And yeah, I mean they set a lot of the standards. It just seems like they make something and kind of like move on to something else, and
Yeah.
it's a little frustrating, but yeah, man, thank you for taking the time to do this. I don't want to take up any more of it. I
No,
hope I
thanks.
see more repos from you.
Yeah, I eventually in the future I will maybe open source my little Pi bot so you can try to replicate it. It's actually a very simple project in terms of electronics. You just need a soldering iron and buy the same robot for €9 from off of Amazon, and you can replicate it. So maybe open source that